Have you ever just stopped and wondered what this source code of the universe actually looks like? I mean, we all imagine reality as this smooth, continuous movie playing out. But what if you could zoom in, way in, and you discover it's all just pixels?
And look, this isn't just some late night philosophical question. This is a question that cuts right to the very heart of physics. Today, we're going to dive into a pretty radical theory that gives a wild answer that the universe isn't some empty stage where things happen. Instead, the universe is a giant computation, and it's built from the simplest thing imaginable pure information. So let's explore this incredible idea, starting with a master blueprint.
Okay, this is our map for the journey. I know, it looks a little complicated, but trust me, it tells a story. And that story starts at the very bottom and builds its way up. It's the story of how a simple grid of bits can evolve, twist itself into knots, and maybe even become self-aware. In this explainer, we're going to decode this thing layer by layer to see how this theory tries to build our entire reality, matter, consciousness, the whole shebang, from scratch. So here's our game plan. We'll start with those fundamental pixels of reality. Then we'll see how they get tangled up to form what we call matter. From there, we'll see how those tangles can form loops that think. Then, how all those thinking loops agree on a shared reality. And finally, what all this means for the ultimate language of the cosmos itself.
All right, let's start at the absolute bottom. The foundational idea here is that space and time, they're not smooth and continuous. They're discrete, meaning there's a smallest possible length and a shortest possible tick of the universal clock. This whole concept was captured perfectly by the physicist John Archibald Wheeler.
Now, what Wheeler is saying here is it's profound. He called this philosophy it from bit. The it, everything physical we can see and touch, emerges from the bit, pure, raw information. So at the most fundamental level you can imagine, the universe isn't made of stuff. It's made of answers, simple yes or no answers. At its core, it's all just computation.
And this is that base layer from our diagram. It's called the Quantum Cellular Automata Substrate, or QCA. The best way to think about it is like a cosmic checkerboard, where every single square is a quantum bit. And the state of any square in the next tick of the clock is decided only by its own state and the state of its immediate neighbors. That's it. Simple, local rules repeated over and over and over that generate all the mind-boggling complexity we see around us. This isn't just a metaphor. The theory proposes this is the literal operating system of our universe. Okay, so if the entire universe is just this informational grid, this giant cosmic computer, then where does all this stuff come from? What are you? What am I? What is this planet made of? The answer, and this is one of the most beautiful parts of the theory, is that matter isn't some extra ingredient you add to the system. Matter is the system.
Right, so here's the crucial idea. Matter isn't fundamental, it's an emergent property. Think about a whirlpool in a river. Is the whirlpool made of some special whirlpool water? No, of course not. It's just a stable, persistent pattern of the normal water. In this QCA universe, particles are exactly the same thing. They're just stable, self-sustaining knots in the flow of information.
So here's how that's supposed to work. You start with this nice, smooth, orderly grid of information. Then some local interaction happens, and it creates a tiny little twist. But this isn't just any twist. It's a special kind that gets stuck. You can't just smooth it out by messing with its neighbors. It becomes what's called a stable topological defect, basically a glitch in the code that you can't delete. And this stable glitch, this persistent knot in the information, well, that's what we perceive as a particle. Now here's where it gets really cool. This abstract idea maps directly onto the real particles we know from the standard model of physics. An electron, for example, is proposed to be the simplest, most fundamental kind of knot you can have. A quark is a bit more complex, like an open-ended knot that has to hang out in a group of 3 to be stable. And what about the heavier particles, like muons and taus? According to the theory, they're just higher energy, more complex versions of these same knots. It's like a brand new periodic table, but instead of being built on protons and neutrons, it's built from geometry and information. So if a simple knot is a particle of matter, what happens when those knots get really, really complex? This is where the theory takes its most audacious leap. It's an attempt to explain the physical origin of consciousness itself. Now, to get this, we have to think about 2 different kinds of cause and effect. Most of the universe just runs on simple mechanical causality, right? A causes B. The cue ball hits the 8 ball. It's a one-way street from the past to the future.
But conscious systems, they feel different, don't they? They have goals, they have agency, and that seems to require a feedback loop. The system acts, it sees the result of its action, and then it changes what it does next. So A causes B, which then influences A. It's a self-referential loop.
And there it is, right at the top of our diagram. The theory proposes that when these informational knots get complex enough, they can form a massive, stable, self-referential loop. We're talking about a system that's so complex it can't just model the world around it, it can model itself modeling the world. This incredible informational structure, this strange loop in the cosmic computer, is what the theory says is the physical basis of a conscious agent.
But hang on. How could a delicate pattern of information possibly survive inside a warm, wet, chaotic brain? The answer is something called topology. You see, this loop isn't just any old loop. It has a special mathematical property that makes it incredibly robust. You can jiggle and shake all the individual bits, but you can't actually break the overall structure of the loop without a massive amount of energy. So the theory basically argues that consciousness is, in effect, a naturally occurring room temperature topological quantum computer. How wild is that?
Okay, but this leads us to a huge, huge philosophical problem. If I am just a computational loop, and you are just a computational loop, why on earth do we experience the same reality? If everything is built from these subjective points of view, why does the world feel so solid and objective?
This is the million-dollar question, right? If reality is constructed by each of us, there has to be some kind of mechanism that forces all of our constructions to line up. And the QCA model says that mechanism is simple. It's communication. The theory calls this consensus geometry. And it suggests that objective reality isn't some fixed background that we all live in. Instead, it's an agreement that we all converge on. It's like a negotiated settlement, a stable middle ground that's been reached after countless interactions between all of us observers.
So here's the breakdown. We each start out with our own subjective model of the world. Then we talk to each other. We exchange information. When what you tell me conflicts with my model of the world, it creates a prediction error, or what the theory calls surprise. And to minimize that feeling of surprise, we both have to adjust our models a little bit. Now imagine that happening over and over again, through every conversation and interaction in history. Our models are forced to get closer and closer together, until eventually they converge on a shared model that is stable for everyone. And that shared, stable model, that is what we call objective reality.
So, let's tie this all together. We've gone from simple bits of information all the way up to a shared, objective reality filled with conscious observers. What does this tell us about the fundamental nature of physical law itself? I mean, this is the grand story of the universe, according to this theory. It's a bottom-up unfolding of complexity. You start with a substrate, the foundation of discrete information. That information gets tangled up into knots, which we see as matter. Those knots can then weave themselves into self-referential loops, which gives rise to consciousness. And then those conscious loops, by talking to each other, build a consensus reality. And the one golden rule that governs this entire process? The simple conservation of information. At the end of the day, this idea reframes our entire concept of physics. The laws of nature, like gravity or electromagnetism, they aren't just some arbitrary mathematical rules that happen to describe our universe. In this view, they are the very syntax of logic itself. The laws of physics are simply the most efficient, most compressed algorithms for running this cosmic computation. Physics, in a way, becomes a branch of theoretical computer science. And that leaves us with one final, absolutely mind-bending thought. If consciousness is, at its core, a topological pattern in an information network, it doesn't have to be biological. It doesn't need to be made of carbon and water. Any system, anywhere, that can support these stable, self-referential loops could, in principle, be conscious. So the question is, what other kinds of minds are out there, woven into the very fabric of the cosmos, operating on timescales and on physical substrates we can't even begin to imagine? The universe might be far, far more alive with thought than we ever knew.